All right, I'm Matt Jones.
I'm Patrick Kessler.
And we did the Boilermaker MINI. So a little bit about our toy concept. We were originally going to do the Boilermaker Special, but since so many teams did that, we decided to do a little research on it. And we came across that a lot of the older Boilermaker Specials had been built around truck chassis, so we're like, well, why don't we just make it into a truck? And in the pickup bed, we actually have the world's largest drum, so that gets our second mechanism. Age range, 3 to 8 years old, or anybody that's a truck or train enthusiast. As far as fabrication and assembly goes, we 3D printed basically the whole entire thing. The windows were, and part of the bottom of the chassis was laser cut acrylic. Spray painted the whole entire thing, and then we purchased a couple parts like the back axle and part of the steering mechanism.
Yeah, as you can see here, there's the steering mechanism of our truck. This P over here is used to control the part and to control the steering. You can slide it from the left to the right side in order to change the directions of the wheels. Moreover, it's connected with this bar over here, which is extended to the chassis in order to give it more stability and make the whole system working. The wheels are fixed on two small pins. As you can see here, these pins go through this connection parts over here in order to make them rotate. And that's the steering mechanism.
And as for the drum, it's located by the wheels. When the wheels turning, the small truck parts will move the hammers back and forward to hit the drum. But unfortunately, when we do some small adjustments, the hammer actually is a little bit off to the surface of the drum. So currently it will not hit it, but if we have more hammer in the future, it will move it a little bit to let the drum hit and it will make a small sound.
The key features of our truck are first of all the motion key, and as I said, it's used to control the steering. The second part is the steering column, which is also a very important part and also pretty critical because this part over here, there's a lot of big moment over here which would make a break, so we had to support it with triangles out of acrylic, which we will see later. And
and the hammer rotator and the hammer, it just like previous showed. With the wheels turning, the hammer rotator will turn, and the two hammer rotator will make the hammer move like back and forward like that. So that's basically how it moves.
So the two main body features we have the chassis and the truck body. The chassis has mounts for every other part. For the back, you can see we have mounts for the drum and the rear axle and the hammer mounts here. And in the front, we have the mount for the steering mechanism, which here we have to move the front variable connection back and forth. And all around the side of the chassis, there are pinholes for the truck body to sit on. And on the truck body, it's just a basic design to have the shape of a truck, and it has a truck bed to let the drum mechanism pop out from the back. And in the front, it has a surface for where the steering P would slide across, so you can move with your fingers and steer the front two wheels. And here's the demonstration of our steering mechanism. If you can put your hand on the P, you can turn it left and right to move the steering, to move the wheels, make it turn accordingly. We have the the car forward, it'll rotate the rear wheels, which will rotate the rotator inside the rear axle, should push the wheels back and forth.
All right, so some potential improvements we could make to this thing. The wheels we were going to get wouldn't be able to be shipped here in time, so we ended up having to 3D print some wheels a little bit later than what we wanted to. They ended up being a little bit smaller than the wheels we actually had too, so that's why it kind of looks a little odd. But also the steering mechanism, we would have added a little bit more structural support to that. We did end up doing that, but we had to do it out of acrylic. And also, if you turn the truck upside down, lots of times the mechanism wants to fall apart. So it's not the most kid-friendly, even though it's supposed to be kid-friendly in play value. But and then second or third, we have the hammer mechanism. We potentially redesign that and use our original idea of the hammers being spring-loaded. We didn't do that because well, originally it was going to be remote controlled, and that was in the budget, and just everything changed. So, yeah.
And for the hammer, for the drum, we originally make the drum a little bit wider than this, but as 3D print has its upper limit, and actually the whole body is 3D printed, so we already reached the limit of it. That's why we decrease the size of the drum. But after we added that, we forgot to add the hammer. So that's why the hammer did not reach the surface of the drum.
Any questions? Or we can go on demonstrate. So one of the drawbacks to this is like when you actually do the steering, you kind of have to like pick it up off the ground because the wheels are so slick. We should have added some type of friction to the wheels. And then the hammer mechanism, for some reason it only works in reverse. I don't know why.
There's epoxy that got stuck into or gluing the rotators, little sinusoidal rotators. So the epoxy got stuck on the axle, which causes a lot of friction now. So you just have to press down. But the video, it worked. So.
So right now the camera is basically reaching so see right now it's not what if we take and try to roll out life cycle. I kind of sense you have some automatic like system that might be
The original spring system was that the rotator would push a rod that was connected to the spring, and it would push the hammer back as the rotator pushed the rod forward. And then it would have a step on it, so that it would fall back and then hit the drum with some force. But for this design, we just had it move linearly in one direction, and we have it so that it has some distance to move. It isn't actually at the drum; it stops before, and then the other rotator acts on the other side to push it back. It has some distance between each rotator, so that there's still enough space between the hammer and the drum, so it wouldn't actually hit.
Yeah, it was a sinusoidal.